Welcome all to Anudeep YourStudyBuddy. We have started with the discussion on the topic matrices. We are going to discuss about the part 2 of this topic. We have already discussed about what is the dimension of a matrix and the multiplication of a matrix. Today, we are going to start with the topic called inverse of a matrix. So let us proceed. So when we are talking about inverse, the name itself, inverse indicates that if I have a number 3, inverse means reciprocal, right? So it is reciprocal of 3, that is equal to 1 by 3. So when we are talking about the inverse, we are getting into finding out the reciprocal, and as you know, the product of a number and its reciprocal will be equal to 1. Same concept we can apply in terms of the matrices. In matrix, whenever you have a matrix, so if I have a matrix A and its inverse, if I multiply, then I get, that is called identity matrix or I. So as you know, I is nothing but if it is two dimension 1, 0, 0, 1. All the elements in the identity matrix, they are either 1 or 0. So this is what we have to remember when we are solving the problem on inverse of a matrix. Then there are two methods to find the inverse of a matrix. First is adjoint method and second is elementary row or column transformation. So today we are going to discuss in detail about what is the adjoint method. So let us look at what are the steps. So when we are talking about the adjoint method, there should be few things that should be clear in your mind. First thing, we have to understand what is a transpose of a matrix. So transpose of a matrix, if you know. Then second, you should also know how to calculate determinant of a matrix. So if you know these three basic steps, then it is easy to start with the step-by-step calculation for the adjoint of a matrix. So there is a formula which says, or there is a definition of adjoint matrix. It is equal to transpose of cofactor matrix. In the previous lecture series, we have discussed about what is the dimension of a matrix, how to calculate the determinant of a matrix. We have also discussed about the compatibility of the matrices for multiplication. And we have already discussed that when we are calculating the determinant of a matrix, it is always a square matrix that we make use of. And what is the definition of square matrix? As you may be knowing, the dimension of square matrix is m by n. So here the row number and the column number, they match with itself. So if there are two rows, there will be two columns in a square matrix. And for such a square matrix, the determinant will be, if I say A is a square matrix of dimension m as to m, then determinant of A for 3 by 3 order, as we have discussed in the previous lecture series, will be the determinant of the matrix A given to you. So you start with the first element at the position A11, multiply by the minor of A11, then minus B, we follow the sequence plus, minus, plus, when we are evaluating the formula. Then minus B into minor of the element A12 and plus C into the minor of element A12. So once you have the determinant of A, then we have a direct formula to calculate the inverse, and that formula is A inverse is written by A raised to minus 1 with the determinant of the matrix A given to you. So you start with the first element at the position A11, multiply by the A inverse as 1 upon determinant of A into adjoint of. So this is the basic formula that we will be making use of when we are calculating the A inverse. So what are the steps? To get A inverse, we should know what is the determinant of A. And if determinant of A is not equal to 0, which implies A is non-singular, that is the condition for the inverse matrix to exist. So that means if A is non-singular, then only we can calculate the inverse of a matrix. Then second step, once you know that it is a non-singular matrix, then you proceed to find what is called a cofactor matrix. And for the cofactor matrix, for evaluating or calculating the elements in the cofactor matrix, the formula which is used is Cij is equal to minus 1 raised to I plus j into Mij, where Mij is a minor of Aij element in the given or original matrix. So from the original matrix, we are going to evaluate each of the element in the cofactor matrix first. This was the second step. And the third step is you take the transpose of cofactor matrix. So these are the three steps, 1, 2, 3, that we are going to follow to find out what is called the inverse of a matrix. So let us evaluate one problem. Here we want to calculate the inverse of a matrix using the adjoint method. When we are going to find out the inverse of a matrix, the first thing that we have to check if given matrix A is non-singular, meaning determinant of A should not be equal to 0. So let us calculate first what is the determinant of A. And as you know, it will be 3 into 1 minus 1 into 5 is 5 minus 4 minus 2 into 5 minus 4 plus 6 into 2 minus 2. That is 3 into 5 minus 4 is 1, that is 3. Here it is minus 2 into again 1, that is minus 2 plus 0, that is equal to 1. And 1 is not equal to 0, which implies A is non-singular matrix. So now we can proceed to find the inverse of the given matrix. We need to find out what is a cofactor matrix. So for the finding out the cofactor matrix, the formula just now we discussed is minus 1 raised to I plus j into mij. So let us discuss the first element. C denote the cofactor matrix. And for the elements in cofactor matrix, this is what is the formula that we will be repeatedly using. Now, as you can guess, there are 3 into 3, that is 9 elements in the given matrix. So there will be, in cofactor matrix also, there will be corresponding 9 elements. So for all the 9 elements, we have to use this formula. So let me try explaining you the first two, and then you can try on your own. So for the first element at the position A11, so C11 will be the corresponding element in the cofactor matrix. It will be equal to minus 1 raised to, now this is my I, this is my j. So 1 plus 1 into M11. Now, as you know, when we want to find out, now it will be 1 plus 1, 2, minor of element A11. So this element we are talking about. And when we want to find out the minor, this is what we obtained as determinant of 2 by 2 order is 1, 2, 2, 5. And you know how to evaluate the, so it is minus 1 raised to 2, that is positive 1. And you know how to evaluate the determinant of order 2 by 2. It is AB, AD minus BC. That is 1 into 5 is 5. Minus 2 into 2, that is 4. 5 minus 4 is 1. 1 into 1 is 1. So for the first element in the cofactor matrix, the answer is 1. Similarly, let us evaluate the second element, C12. Now, for C12, we have to refer to the element that is A12. So here again the formula becomes minus 1 raised to 1 plus 2 minor of A12. So minus 1 raised to 3. And here it is M12. So here it will be 1, 2, 2, 5. And if you can see, it is minus 1 raised to negative 1. And it is 5 minus 4, giving me again 1, but 1 into minus 1, that is minus. So this is how we are going to calculate cofactor elements, that like we have 9 elements in A, we will be getting 9 such corresponding element in the cofactor matrix. Let us evaluate it further. So like we have calculated the elements C11 and C12, let us now calculate the other elements in the cofactor matrix, that is C13, C21, C22, C23, C31, C32, and C33. Using the same formula, Cij is equal to minus 1 raised to I plus j into Mij. So this is how you will be getting when you evaluate. And finally, we can write the cofactor matrix element in its position, and we obtain it as 1 minus 1 0, 2 3 minus 2 minus 2 0 1. So after calculating the cofactor matrix, then we can find out what is the adjoint of A. It is equal to the transpose of cofactor matrix. So whatever the matrix that we have obtained, if you interchange the row with the column, we'll be getting its transpose. So to obtain adjoint of A, let me transpose, take the transpose of C, will be 1, minus 1, 0, 2, 3, minus 2, minus 2, 0, 1. So I'm just writing this row element as column. Now, so now we have adjoint of A with us, and we also have the value of determinant of A. So by using the formula for inverse of a matrix, which is 1 upon determinant of A into adjoint of A, we can find out the A inverse. So let us substitute the values. It is equal to 1 upon 1. And the matrix itself, so 1, 2, minus 2, minus 1, 3, 0, 0, minus 2, 1. Because it is getting multiplied with 1, this is what is the final answer. So today, we discuss about how to find the inverse using the adjoint method. So what are the steps? So first step is you first of all calculate what is the determinant of A. That is, this matrix A should be non-singular. If it is non-singular, then only you are going to proceed for calculating the inverse of the given matrix. And when you are finding out the inverse, we have to calculate what is called adjoint of a matrix. And for that, we need to calculate what is called cofactor matrix. And to calculate the elements in the cofactor matrix, We'll be using the formula CH is equal to I plus J into NH. So these are very simple steps, but in board exam, you will surely get a problem, maybe on actual method or by using a row or column transformation method to calculate the inverse of matrix. So do prepare this topic well. I hope the steps are very much clear to you. See you very soon